Alright, in this video we're going to talk about Unit 2, Objective 11, parametric functions. So you should have watched the short video on parametric functions, what they are. But as a quick reminder, parametric functions are those that do not relate x directly to y, but instead they're going to relate x and y to a parameter called t. So we're no longer going to have y equals 3x plus 4 or x squared plus 3xy plus 2y equals 7. We're going to have things that look like x equals some function of t and y equals some function of t separately. So x and y are not going to be related in any way. So the rules for differentiating parametric functions. So we still want to know what dy dx is. The problem is we don't have y in terms of x, right? This is the derivative of y with respect to x. What we can do is we can take the derivative of this piece, which would be dy dt, and we can divide that by the derivative of this piece, dx dt. And if you think about what's going on here, to get to dy dx, you have a fraction divided by a fraction, so you multiply by the reciprocal. Your dt's are going to cancel out, and your dx is going to be in the bottom. So dy dx is the derivative of y divided by the derivative of x. Now things get a little goofy when we take the second derivative. So the second derivative is going to be the derivative of y prime with respect to t. So take the derivative of what you just had with respect to t, and that's going to be divided by dx dt again. And that's a chain rule and a quotient rule issue. But it's not just as easy as taking the derivative of the derivative. You have to take the derivative of the derivative and then divide by the derivative of x again. So a couple examples to look through with the calculus. Find dy dx if x equals cosine t and y equals sine t. So dy dx again is going to be the derivative of y. So we'll look at dy dt first. Derivative of sine of t is going to be cosine of t. We want to take that and we want to divide it by the derivative of x with respect to t, which is going to be negative sine of t. And we divide. So dy dt over dx dt gives us dy dx is going to be equal to negative cosine of t divided by sine of t. So the negative from here I just put in front. Or if you want, we can call that negative cotangent of t. The next thing we can look at is finding out where we have vertical and horizontal tangents. So vertical and horizontal tangents, we need the slope of the tangent line. So again, we're going to need our dy dx. So to get dy dx, we got to take the derivative of the y piece, which is going to be 1/2 t to the negative 1/2 power. Or if you want to think of it as this, we can do that. Dx dt is just the derivative of the x piece, so that's going to be 6t. So dy dx is 1 over 2 radical t over 6t. So if we want to, we can think about this as 1 over 12t radical t. Right? If you have this over 1 multiplied by the reciprocal, or if you want to, we can also say 12t to the 3/2 power. So then we got to think vertical and horizontal tangent lines. Vertical tangent lines means we have a vertical line, so the slope is going to be undefined. So we have to look at what our slope is. When is the slope going to be undefined? Well, a fraction is going to be undefined when we have a 0 in the denominator. So we're going to have a vertical tangent line when t equals 0. For a horizontal tangent line, we have to think the slope is going to be 0. So we have to try to figure out when 1 divided by 12t to the 3/2 power is going to equal 0. So whenever we have fractions and we're trying to find when that fraction equals 0, we have to think about when the numerator is 0. So 0 divided by a number is going to give us that 0, so we're looking here at a 1. 1's never going to be 0, so horizontal tangents don't exist. We're never going to have a horizontal tangent with the parametric function x equals 3t squared minus 6 and y equals square root of t. So vertical, we've got to set the denominator equal to 0 because that's going to make our slope, our derivative, undefined. And if we're trying to find horizontal, we want to set the numerator equal to 0 because that's going to make our entire fraction equal to 0. So we have one more problem, and that's the second derivative problem. So find the second derivative of y with respect to x twice of the function defined by t squared minus 5, or x equals t squared minus 5 and y equals 2 sine of t. So we've got to start where we have been. So we need the derivative of the y piece is going to be 2 cosine of t. The derivative of the x piece is going to be 2t. So dy dx is going to be the ratio of those two things. So we're going to divide them. 2 cosine of t over 2t. We can cancel our 2's. Cosine of t over t. So that's the first derivative. The second derivative, so the second derivative of y with respect to x twice, is going to be the derivative of this. So we have to use quotient rule here. So low d high minus high d low all over low squared. And that's not all we have to do though. We still need to take into account, we need to divide all of that stuff by dx dt, but we already found dx dt is 2t. So we can simplify this a little bit, think of this as over 1 multiplied by our reciprocal. So we can say negative t sine of t minus cosine of t over 2t to the third. And if you want, we can factor out a negative 1 and throw the negative out front of everything and just say negative t sine of t plus cosine of t over 2t cubed. So the trick on that one is when we're differentiating parametrically, we have to remember the second derivative is not just the derivative of the first derivative, but the derivative of the first derivative divided by the derivative of the x piece. So that's going to do it for this video. We will see you in the next one.